My name is Jorge Jarque. I came from Barcelona Supercomputing Center. In the group, I'm working as a researcher in the group of workflows and distributed computing. And I'm going to present our work that we have done to execute transparently scientific workflows in Docker containers. So this is not just my work. It is a work of a team that Victor, that is an undergraduate student, and Christian, that is a PhD student, and all the work was coordinated by Rosa Badia, that is here also. Yeah, well, when we try to execute scientific workflows, these scientific workflows are parallel applications that are executed in supercomputers. Well, like this one, that is Mare Nostrum, that is the supercomputer that we host in BSc. And the access to these supercomputers, you have to request a special access. And also the permissions are very limited, so they are very difficult to port applications from one system to another. And if you want to run one workflow, one application in this system, you have to accommodate your application to the libraries and all the software operating system and so on that is installed in this computer. So you can have several weeks to have your application running in all the nodes. So all the experiments that you do in these supercomputers are difficult to reproduce and reuse in other systems. So with this idea, what we propose is to integrate our tool that is called COMPS with Docker containers. COMPS it's a programming model. We will see later more details. That is, it detects the implicit parallelism of the sequential applications. It is a platform-agnostic programming model, and it allows to distribute the application in a distributed fashion. And also Docker, for us, what offers is the portability and the reusage that if we can encapsulate our applications in Docker as Docker containers, we can reproduce and reuse in whatever system. So just a brief overview of COMPS. What we have, COMPS is a task-based parallel programming model that the goal is to facilitate the development of parallel applications for distributed computing. We have we support three languages, high-level languages: Java, Python, and C++. And the idea of this model is that a part of the code that is several times used in the application, we define this function or this part of code as a task, and we indicate the direction of the parameters of this method or this task. So from this sequential code, what we get is this task dependency graph, where each of these calls have nodes in this graph. And the runtime detects the parallelism inside this task and make a task analysis and schedule this and execute these tasks in the different distributed platforms. Okay, doing all the file transfers and spawning the processes in the different things. So the same application, the idea is that this application can run everywhere. So. So how we work together with COMPS? We have one command that is run COMPS, that once we have developed the application, we can run locally or in a cluster the application. So what we have created is a run COMPS Docker script that what we do is we build a Docker image with the current application and the runtime system and whatever, and then this Docker image, we create a container stack between the different parts of our runtime, and then deploy in a short container or Kubernetes container system to deploy the container and execute the application. So this is more or less the overview. So now we will enter in the details. So what we do when we run this transparently, when we run this run COMPS Docker script, is that we create the application Docker file. When we copy this application to an image that has included the operating system, in this case Ubuntu, and also the COMPS runtime. Then with this Docker file, we execute Docker build and we create the application image. So now we have the application image. Now it's time to deploy and create the application with this image. So what we do is that COMPS is running in a worker master mode. So the main code of the application it's running in a master, and all the tasks are executed in the worker nodes. So what we create with this is what we automatically create an application compose when we create one container for the master and several containers as indicated by the user as workers. So, and with this application compose, what we have is that Docker facilitates for us all the networking issues and all the systems will be connected to each other. So this compose, for the master and the worker, we will have the image that we have created in the application. So this compose with Docker Compose will be submit to a Docker Swarm infrastructure that in every Docker node we will create, we will deploy and run the master container and the worker container. So this is mainly the overview of how we, from an application that has been implemented with COMPS, we deploy automatically and transparently to a cluster of Docker nodes. So another feature that we have is that, so in the COMP runtime we know the graph of the application. So we can know that, for instance, in this region we don't have parallelism, but in this region we have a lot of parallelism, and then in this other region we have less parallelism. So what we can do with the runtime can detect how many pending tasks are in this phase. And then in this case, it can contact to the Swarm API to create another worker container, just to speed up the execution automatically without doing any kind of user interaction. So, and declaring any kind of rule to make the elasticity. The runtime automatically detects how many tasks are pending, and then it creates as many containers as they need to speed up this application. And when we reach this reduction phase that we have less parallelism, then we can skip this, remove these containers. So we adapt the resources to the needs of the application. So, basically this is all what I want to tell to you. Just to recap the things is that the integration of COMPS with Docker, what we have is that from a sequential code we can detect the implicit parallelism by detecting the data dependencies. Then transparently with this run COMPS Docker script we can create the images and deploy the containers in a Docker infrastructure. And we have seen that this can be self-adaptable, and also for doing this, for a scientist that does not have any knowledge big knowledge of computer science can easily program their applications with no big knowledge of parallelism and distributed systems, and also they don't need to care with the complex configuration steps that they have to deal in the supercomputers. So when applications are packaged in Docker images and they can send to another colleague and they can reproduce the experiments and reuse your code very easily, just running again the run COMPS Docker script instead of doing all the installations in the supercomputers and these kind of things. So thank you for listening me, and then you can download the COMPS runtime and the COMPS programming model, and also you can see application examples in here. You have also the support mailing list, and also you have the Docker image here that you can play with COMPS and Docker. So thank you very much.